All right. Yeah, you want to let this down. So we're gonna make. We won't get through a whole lot today. We've got like 3 days of lecture in this, so this is kind of a lot of info, and that's okay. It's really interesting. Okay, so some terms that we need to know before we move on. Talked about atrium and ventricle already. Let's look at them in your heart. So everybody hold your heart. Do I have to open? She just said to hold your heart. Oh, yeah, go ahead and open it. And actually look on with someone. All right, so the atria, remember, are the upper chambers of the heart. So when you look at your heart, okay, you should see kind of 4 rooms, basically, or your 4 chambers, okay? So the atria are the upper chambers on both sides. Okay, excuse me. Now, remember, we're going to talk about right and left. So remember, anytime you're talking about right and left, it's always the patient's right or left. It's not your perspective, it's theirs. So when you look at the heart, the way it's situated in the body, okay, looks kind of like this. So it's actually in the middle, but there's more of it on the left, if you will, because of the way that it's angled and turned. So that's what you'll see. So the atria, which is plural for atrium, those are these 2 at the top of here. And if you look on the back, you can kind of see how they're twisted. The left ventricle, or the left atrium, is kind of really almost all the way to the back, and the right one is kind of on the side. Okay. So those are the atria. Okay, the ventricles are the lower chambers of the heart. Those are these down here that have kind of the lungs and stuff in them. Okay. All right, what are some differences you see between the atria and the ventricles? What do you think?
The atrium is bigger.
It appears that way, but no, you're good. It does. These hearts are kind of misleading. It does look that way. Really, the ventricles are larger. Sorry, it's just because of the way that these open and turn. You're fine. What are some other things you notice? Okay, one's more rough, bottom, a lot more muscle. Okay. What about the walls of the heart? What do you notice? Okay. On these, they're darker. Those they're not. That one's got some myopathy going on. That one's diseased. There's another diseased one too. It's got a big spot on the outside. It's going to be one of those too. Maybe not. It might be Ashley's own. Okay, so notice down here, okay, that the walls are a lot thicker. That's because, okay, the atria actually accept blood into the heart. So when blood comes from the body or comes from the lungs, it flows directly into the atria. Okay, then blood goes to the ventricles. So where does it go from there? Down there. Yeah, it goes back out of the heart. So it either goes to the lungs or it goes to the whole body. So the ventricles have to be a lot stronger than the atria because they're sending blood out, right? So the walls are much thicker. Which wall is the thickest? The middle one? The left side? Yeah, it's the left side. So the middle one and the left. Okay, that's because that one is pumping blood to the whole body. So it needs lots of muscle, really thick muscle, to pump blood all the way out. So the left ventricle is the largest chamber. Okay, the left ventricle is the largest chamber. And that's why, because it's got to pump blood all the way out of the heart and through the whole body. You say if you were to put a heart on the ground, it pumps so forcefully that it would shoot blood 30 feet in the air. Like if you were just to set it down.
I'm really scared. How do you know?
I don't know how they know that.
They try it?
I mean, I didn't try it. I guess they probably measured a force to do that. I mean,
It is really without somebody's.
so it's pretty crazy. All right, so valves. Okay, a valve is just an opening, right, or a door that allows blood to move through. Okay, it's an opening or door, if you will, that allows blood to move through. And there's 4 valves in the heart. There's 2 types of valve. First ones are called the AV valves. AV stands for atrioventricular. So where would you expect to find those? In the middle of what? Right. So atrioventricular, right? You hear the root words for atrium and ventricle in there. So your AV valves are these 2 valves that are between the atria and the ventricle. So the ones that have the strings on them. Those are, there's 4 valves total. Yes. These are the AV valves. So you have a right AV valve and a left AV valve. Right.
So one of mine got ripped off.
Yeah, that's possible.
What are the little white things?
Yeah.
Yours are like, mine are broken.
Yeah. So the right AV valve, we're going to talk about it in a minute again, is called the tricuspid valve. The left one, you don't have to write this down, so it's on a different slide. The left one's called the mitral or bicuspid valve. You've probably heard of the mitral valve before. Some people call the mitral valve prolapse. That's what it comes down to. Anyway, so that's those. The other 2 valves are called semilunar valves. And if you look at your heart like this, look here, if you'll turn it upwards, okay, and look, you can see the other 2 valves. They go into blood vessels.
I don't see
What?
That's not red.
What?
They're right up under here.
Oh,
They may be on the other side. See, there's just one right here, and there's one right there. That one. Yours just are a different color. I don't
I don't know what mine are.
Yeah, yours may not.
Can you turn it
No,
the
it
other
does,
way?
the white ones. I see
Oh,
that.
It's that hole there and that top.
Yeah.
It's on that one.
It's not so the semilunar valves let blood enter into blood vessels. So the pulmonary valve or pulmonic valve is this one on top that has the blue artery that's running from there. Okay. And then the one underneath in the middle kind of that's connected to this really large red artery, that's the aorta. So this is the aortic valve.
Oh.
This is a clog real bad.
Do what? What'd you say, Gabe?
Which one goes on?
It's like
Pulmonary artery. Pulmono, remember, is the root word for lungs. So, actually. Okay, so that's the valve. Those are your valves. Endocardium. What words do you hear there?
Cardio.
Cardio is heart. Endo is inside. So endocardium is the innermost lining of the heart. Innermost lining of the heart. Innermost lining of the heart. So this is what lines the inside of the heart. It's really important that it's really smooth. Should be really, really smooth. Why do you think that would be important? That's exactly right. So blood doesn't stick to it, right, and clot. Because if you get a blood clot in your heart and it sends it to a blood vessel somewhere, you're going to be in trouble, especially if it sends it to your brain. So it causes a stroke.
How come people say having oxygen or like air in the blood is bad?
It's called an air embolism. You get a whole lot of air, and it's just, I mean, air's moving through there, and there's no oxygen or blood moving through. It actually takes a lot of air to cause a problem, but it's not like you're sitting there and your IV's going and one little bitty bubble drips in, and you're like, I'm about to die. It's not like that. It would take like
Yeah, with like
a lot of tubing. Yeah, I mean,
people would make me feel about like.
you don't want bubbles in there. I mean, you don't want that, but
How come like everybody says your blood is blue until it reaches oxygen?
Yeah, I've
Usually
heard
the
that.
oxygen makes it red. I don't know. I've
Yeah,
never seen it
I've
when it
heard that
wasn't
my whole
touching
life.
oxygen. So
One of those.
You like always touching oxygen though? 'Cause it's always
oxygen in it. So. Anyway, so endocardium is really smooth, inner layer of the heart. Another reason it's really smooth, it's made out of epithelial tissue, so it doesn't allow for a whole lot of movement of oxygen. The way that your heart gets its own, if you think about it, your heart has to have oxygen too, right? Because it's a muscle, and in order for your cells to work, they need oxygen. Well, it doesn't just absorb oxygen from the inside. See all these blood vessels on the outside of the heart? And they kind of wrap around it. All of those arteries, okay, is what carries oxygen to the heart muscle. So it actually gets its oxygen from the outside. And if you look, y'all may not have it, especially that little bitty one. But if you look at the base of the aorta, the really big red artery, there's usually a little bitty blood vessel that is coming off of that. There may not. Some of them are more detailed than others.
This guy has an enlarged.
That one's a really old one. I don't know how long. So.
This one's enlarged.
But that is where the blood starts, right? Those blood vessels start that actually feed the heart muscle its oxygen. So when someone has a heart attack or a
Stroke.
what's the other word for heart attack?
Oh,
Do what?
yeah. So,
Well, cardiac arrest is
Yeah,
when your heart
MI.
stops.
Yeah.
MI, which is
You
you better learn it before
Molecular.
myocardial infarction. Okay? So what happens with an MI is that one of these blood vessels on the outside of the heart, or typically what happens with an MI, rephrase that, gets clotted. Maybe it gets too much, maybe it's got so much plaque buildup that it's finally closed off completely, or a blood clot has traveled and it has stopped up. So for example, if it were to stop up this blood vessel here, this artery, right, no oxygen is going to get past that. Now listen, no oxygen is going to get past that. So that whole area where that particular artery feeds is going to die. It doesn't need oxygen. Well, when one part of the heart dies, that's what causes it to go into like a bad rhythm, causes a heart attack. Now, if it were going to be a huge blood vessel, like if it were this artery here that's feeding this whole side of the heart, right, if it got clotted or if it got stopped up completely, that's going to cause like a massive heart attack. It would damage most of the muscle, may not be repairable. So that's how a heart attack works. It actually is the outside, usually it's the outside of the heart. Now there could be a blood clot inside the heart that could cause it too, but that's that. All right. Okay, myocardium. Right, it's the heart muscle. So this is the middle layer of the heart. It's all the muscle layer. And you can see it on yours. Remember around the left ventricle, it's really, really thick so that it can make blood go through the whole body. The middle layer of the heart, or the muscle layer of the heart. Your heart actually has a very special type of muscle tissue, different than other muscle. All right, the pericardium then would be around the heart, right? So it's the outer layer of the heart. And it's a double layered membrane. It kind of allows for movement. But pericardium, it's around layer, outer layer of the heart, around the heart. Okay, arteries are blood vessels that carry blood away from the heart. A for artery, A for away. Easy way to remember those. A for artery, A for away. So blood vessels that carry blood away from the heart. Okay, now, what color are arteries usually when you look at them in a book or something? red, right? Because they carry
Blood.
oxygenated blood. There's one exception to that. So you can't always go by arteries are red and veins are blue. Arteries carry blood away from the heart. So make sure you learn it that way. Because the pulmonary artery, this right here, is blue. Why is that?
Is that this one for me?
Yes.
Isn't it taking out
Wait. Yes.
like the
Right. Well, this is blood that has not yet gone to the lungs. So it still doesn't have oxygen yet. Okay. So it is going away from the heart, but it's going away from the heart to the lungs. So this is like the most deoxygenated blood you could probably get. I guess. I don't know. I don't really know why it's like that. So that's the exception. Okay. Veins go back into the heart. That's how I remember that one. Vein has I-N, so it goes back into the heart or back towards the heart. Okay, so veins move back towards the heart. So same idea. Normally veins are blue, but I want you to remember that they come into the heart because there's one exception, and that's the pulmonary veins. So that's these 4 veins on the back. Okay, they're coming back from the lungs to the heart. They're like about as oxygenated as they can get. Okay. All right, capillary. You might know what a capillary is.
Tiny blood.
Blood vessels, yes. So capillaries are the tiniest blood vessels where gas exchange occurs. Tiniest blood vessels where gas exchange occurs. Okay. So capillaries are so tiny, okay, that sometimes only one red blood cell can fit through at a time. They're like in line, like a lazy river, you know, really small. So that's kind of, think of it that way. Now gas exchange occurs there because the walls of capillaries are really thin. They have like one layer of tissue. So the reason that is that capillaries is where oxygen leaves the blood and enters into your tissues, and carbon dioxide leaves the tissues and enters back into your blood. You may remember my biology lesson maybe last year. Why is carbon dioxide why is that the waste product? Where does that come from?
just the air plant?
Well, y'all remember learning about cellular respiration? Everybody remember that? Okay, so your body uses, right, oxygen and glucose, right? And the result is water and carbon dioxide. Okay? So that happens. So your body uses up oxygen, right? Uses up glucose, right? That's the energy it needs. And then carbon dioxide is like the waste product that's left over. So virtually what happens with your capillaries, go to this picture real quick. Okay, so I know this picture is kind of weird because it's all spread out, but stick with me for a minute. So basically what happens is your blood leaves your heart, right? Heads all out to your body, all over the place. Okay, so it goes all the way down to your toes. Well, at the end, basically these arteries get smaller and smaller and smaller and smaller and smaller until it reaches the capillary bed. It's kind of like this big web, like interwoven web of capillaries. So it's not like your blood, you just cut open your finger and it's just like blood's just pooling in there. You're actually cutting vessels or capillaries, and that's what basically. Well, these, it's just like a big bed. Okay, your whole body basically is a big bed of capillaries. Where these have gone to it, that exchange occurs. Oxygen leaves the capillaries, goes out into your tissues. Carbon dioxide gets back in the bloodstream, and then it's right back up to the heart.
So after you cut them, how do they heal?
They clot, and then they just heal themselves. So the lining of the blood vessels repairs itself pretty quickly usually. but clotting is part of that. There's a whole process. It's like a multi-step process. How our blood clots and heals back up, forms a scab and all of that. So that's, let me see as that goes through. Everybody understand capillaries? Okay. So when you think about the pressure that it takes for your heart to force blood through the body, okay, we talked about what happens as those blood vessels get smaller, right? It's going to take more pressure to push them through. So it takes all that pressure, comes from the left side of the heart, all the way through these arteries and arterioles until you get all the way down to the capillary. Then it starts to come back up. Problem is there's not as much pressure, obviously, back here because it's gone through these little bitty capillaries. So your veins actually have they have valves in them, and you can a lot of times you can see them, especially in your hand. If you kind of make the veins in your hand pop out, a lot of times on those veins you'll see like a little nodule on them, especially where like two veins split or a vein splits or something. Those nodules are usually valves. They just keep your blood going one direction so it doesn't head back down and it will actually go to your heart.
Can you like to damage those valves?
Yeah, I mean, so when you start an IV, I've started IVs before and hit a valve, you have to go through it. But yeah,
Like
but it's,
harder or
I mean,
something?
it can be.
Pretty weird.
But
Let's get someone.
so that's our capillaries. Aorta is the largest artery. Oops. It's the largest artery in the body. This really big one that comes off the top of the heart. It actually goes, if you look in that little guy, it goes all the way down the belly until it splits
The red one?
to the iliac arteries. Yes, the red one. And it's got lots of branches that come off of it. Go to the kidneys or go to the liver. But it like loops back up and behind the heart and goes all the way down. So when you're looking at this, that's where you see it. Yeah, aortic problems are a big issue. Think about like an aneurysm, if it were to rupture or you got something going on with your aorta, it's a big problem because it feeds, every bit of blood goes through the aorta at some point. And so it's huge. I mean, it's so large, it's got a huge diameter. All right, hemoglobin. What word do you see in there that you know? Hemo is blood. Okay, so your hemoglobin they're located on your red blood cells, and that's what gives your red blood cells the ability to carry oxygen. So hemoglobin gives the red blood cells, or RBCs, the ability to carry oxygen. So you guys, some of you guys might have donated blood. And some of you don't. But they always talk about your iron level. Okay, if you've ever been told your iron level was low or something, they're really not looking at iron per se. They're looking at hemoglobin, and that's because hemoglobin uses iron to carry oxygen. It has to have iron for it to function. So when you don't have enough iron, your hemoglobin doesn't work like it needs to. Your blood doesn't carry oxygen like it. That's where that goes. Do what?
How can they tell?
They check your hemoglobin level. They do it. It's just a little finger prick. They have a little machine
Oh,
that
no.
checks it.
It's
they
not
have to
just
use
little
your
finger.
Yeah, it hurts.
It hurts worse than the big needle. The big needle going in your arm don't hurt as bad.
How come they have to use your
Why do they
finger?
do it?
Can't stop.
Capillaries.
That's what all your nerves
Why
are.
can't they turn it down? It doesn't have to be that bad, does it?
Well, I think they have to get quite a bit of it to check
Oh,
hemoglobin.
man.
It's not like blood sugar only takes one drop. It takes a little bit more than that to do hemoglobin.
And it's like, come on.
And if you get it too small, if you don't make the hole big enough and for the blood to come out, then it can what's called hemolyze. And basically, if you press too hard or if you have to press too hard to make the blood come out, it will rupture those blood cells, and then you'll get a faulty reading. It'll get like some kind of crazy reading. Like one time, pulled some blood out of an IV one time because I really didn't want to stick them again. And it said their potassium was like 15 or something crazy. And I was like, that was not even close. So,
Sorry about that.
yeah, no, we knew it was something major wrong. They would have been dead. So, all right. And the last one here is thrombocytes or platelets. What word do you see in thrombocytes? Thrombo is a payday word this week. So, site is cell. Thrombo is
I'm gonna study tonight.
clot. So thrombocytes are your clotting cells or platelets. Those are your clotting cells. So you bump your arm, you cut your finger, whatever. Platelets or thrombocytes head to that area to make it clot so that it can stop bleeding. And then the healing process occurs. Okay. Yeah, if you have too many of them, sure. People don't have thrombocytes or don't have enough, they have hemophilia. That'll stop bleeding. All right, we got to go through this flow of blood and then we'll be good. So this next slide, this is the flow of blood through the heart. So basically the way that blood moves through the heart. So we're going to look at it with your hearts. Okay. This, you'll have a quiz over next, I think I put it on Wednesday. So I think it's next Wednesday. And you'll have a word bank that will have all this in it, but you'll have to put these in order. Okay. So take your hearts. So it starts with the superior and inferior vena cava. So if you turn your heart on the back, kind of see the vena cava are veins. So these are veins that go from your body into the heart. So the superior means, yeah, top or above, inferior below. So this is the superior vena cava and the inferior vena cava, and they both head into the right atrium. And you might be able to see in yours where they move in. Okay. So head to the right atrium. Then blood goes from the right atrium through the right AV valve or the tricuspid valve. I always remember tricuspid, thank you, because it has an R in it. I don't know. Although so does mitral, so that may not help. But tri and right. Here's just term.
How are they like blood going? Are they really,
Well,
like,
these cords are connected to the muscle, so when the muscle contracts.
I'm gonna go get tissues. I'm back. I just brought my own back.
So, anyway, so when the muscle contracts, it actually pulls those open so it can move down.
So they're not actually connected together.
Well, yeah, I know they don't show it on here, but no, it closes off. Yeah, that's actually what you hear. So when you hear a heartbeat, like when you put a stethoscope to your chest, you're actually hearing blood hit those valves because they're closed.
That hard?
Okay, so tricuspid valve goes to the right ventricle, okay, down here, so follow along. And then, okay, so when the heart squeezes, okay, or it contracts, it pushes blood from this right ventricle back up through that pulmonary artery, or pulmonary valve first. Okay, pulmonary valve is this. Do it. I don't know why I'm So pulmonary valve to the pulmonary artery. Okay, so all that pressure forces that open and pushes it. Then it goes to the lungs, right? It goes from the pulmonary artery. That's why it splits. If you look at it, it splits in the right and left sides because it goes to the right and left lungs. Okay, so it goes to the lungs, picks up oxygen, comes back through the pulmonary veins. If you look on the back, it's these 4 veins. You'll see how they're all together. And they all go into the left atrium. Okay, so left atrium, then blood goes through the mitral valve or the bicuspid valve. It's on the left side, that left AV valve. Left ventricle, which is the big one. And then it's forced, all that pressure is forced through the aortic valve, back up through the aorta to the body. So I think it helps to hold these because when you look at this on paper, you're like,
Yeah.
it's like, but you can see how they crisscross with these on. No.
You should dance.
I think that'd be a good
A
one.
little bit flat.
How about you? How about you?
Okay. So that is the flow. That's what you need to know. But you're welcome to study with these.
Can I have this?
So if you look at this is basically like a two-dimensional, right, where they flattened it all out.
Oh,
So you
man.
can see it comes in from the body, inferior vena cava, superior vena cava, right atrium, tricuspid valve, right ventricle, pushed back up through the pulmonary or pulmonic valve, pulmonary artery to the lungs, push up oxygen, comes back in through the pulmonary veins. Okay, left atrium, tricuspid valve or mitral valve, left ventricle, aortic valve, and then it's pushed back up through to the bottom. It's just a big systematic pump. Right? Pretty cool when you actually can see it and hold it and figure it out. Okay, and that's it.
We'll see blood shooting out.
All right, if any of you other of you guys have your hall passes, bring them tomorrow.
I'll have two more tomorrow. Yeah.
So,
I'll bring some more fine
wait
cake.
for me to do this. See,
Do what?
Fine cake.
insert that assistant and there's as junior, I'm
Well, you would have started it this semester. But there's a chance